Hello, friends. So, today we are going to learn about the differentiation and what is the differentiation, how it works. So, we'll understand in the high level. So, before understanding the differentiation, I think I'm just assuming that all of us know what is the slope. So, basically, if we don't know slope, then I will give a very high level understanding on the slope. So, basically, slope is a m. Here m is the slope and slope is equal to y2 minus y1 by is equal to x2 minus x1. Also we call it as a tan theta. So basically this slope is nothing but if suppose you are currently at the point this and this is your y coordinate points. So whatever delta of y and whatever delta of x, which means the difference between x1 and x2, same a difference between y1 and y2. So the difference between y2 and y1 and difference between x2 and x1 is nothing but a slope. So slope have a three things. Two things we just have to remember in a slope. So one is the two things we have to just remember in the slope. Delta y minus by delta x or tan theta. So theta is the angle between the this line and this is the theta. So these will also give the same output and this is our slope. Now come to the differentiation. This I just given a very high level understanding on the slope. Let us come to the differentiation. So what is the differentiation? So before so basically the differentiation we have already explained that what is the differentiation in the previous chapter. I would like you to go to that previous topic. So basically the differentiation we understood that so sorry we understood what is the slope. So slope is a basically difference of change in y divided by change in x. So assume that we have a function called f of x and that is equal to just I'm taking an example that is equal to I mean suppose we have a function called f of x and there is a minor change in x. So minor change in x, and based on that, suppose someone asks what will be the slope. So this will be the slope. F of x plus delta of x minus f of x. So this f of x is nothing but your y2 minus y1 in same way x2 minus x1, the below one, the one which I explain you here. Y2 minus y1 divided by x2. So same thing here also I am telling you that f of x is nothing but a y. Okay, and that is this will be the slope, this will be our slope. Now from this slope we want to uh, mm, derive our dy by dx differentiation formula. So this we are taking a limit delta of x is equal to 0. For this formula, this slope we are taking, why we are taking delta of x is equal to 0? Because we are assuming the we are taking the closest lowest value to the 0. So this delta x is a very negligible, very small. Correct. Okay. Now this is the derivation for dy by dx, this particular theorem, and just we are saying that dy by dx is equal to f of x f of x plus delta x minus f of x by delta x, and we will just prove it here. How we will prove? So let's take a x is equal to x square, x is equal to x square. Okay, so what will be there? X is equal to x. So this is the f of x. So suppose f of x is equal to x square. If f of x is equal to x square, which means x plus delta of x to the power whole minus x square. So because f of x is equal to what we are saying, that f of x is equal to x x square. We are saying f of x barabar x square. So from that formula, it's become this. Now we'll do the x square, the square of this, and we'll get this, and then some will be subtracted, and finally this will be the output 2x of delta of x. We initially said you that a delta of x is nothing but the lowest value. So lowest value will be negligible here. 2 of x plus delta of x, we can ignore the delta of x, and hence the output will be 2 of x. So the dy by dx for x square will be 2 of x. So the formula we get from this is this: d of x to the power n by dx is equal to a of n x to the power n minus 1. So whatever power will be there, that will be multiplied, and power will be subtracted with the 1. Got it. Okay. So this is the dy by dx. Here also we are showing some of the examples, like if d of dx 5 of x to the power 4, then what will you 5 into 4 into x to the power q, and we'll get 20 into x to the power q. So basically 1 minus 1 subtracted from the power, it become 3, and the power multiply is become 20. So 20 of x of q. Now where we will use this differentiation? What is the main purpose? So let me give you one very good example that where we can use this differentiation. So you have seen lot of time different type of graphs. So suppose you have given this kind of graph, and someone ask you to find the maximum height. So this is our h and this is our t. This is our t and this is our h. Now this is the equation. How the graph, how we draw this graph? By putting different value of t, we got a different value of x and y, h and t. Based on that, we draw a graph. Now someone asks that what will be the maximum value of h? Then it's very difficult. The maximum value of h. In general, without differentiation, it's difficult. But we have one very good concept called differentiation, which recently we learned. We can use that concept to find the maximum height of this graph. How we can do that? So we can simply differentiate this equation, and if we differentiate this equation, so I said you early that if it is a constant, the differentiation of a constant will be 0. Differentiation of 14 of t, because t has a power of 1, so 1 minus 1, it will be 0. So t to the power 0 means 1. So 14 into 1, it will be 14 minus 5 into 2 to the power. So here t to the power 2, so 2 will be multiplied. So 5 into 2t, and it will be 10t. So this is the equation. Now the idea is to find the maximum value of maximum height. So to find the maximum height, we just have to find the slope where the slope value becomes 0. So this is the slope. As I said you, the what is the meaning of differentiation? So differentiation is nothing but a slope. So this is also a slope. This is a slope, and slope is equal to d by dl. So whatever equation we have, if we differentiate that equation, then output will be slope. And for that slope, if it is equal to 0, whichever value it becomes 0, that will give the maximum height of this graph. Basically any graph it could be, but for that slope, if it's equal to 0, so here from this graph we can calculate the value of t. See, it's a t is equal to 1.4. Now we got the value of t. We can put the value of t in the original equation, 3 plus 14t minus 5t square, and that's what it has done here. And it will get h is equal to 12.8, which means the maximum height is the 12.5. So from this graph also you can see the maximum height is 12.5, and that is for slope is equal to 0. So we understand the concept of slope in a differentiation. So differentiation is nothing but a slope. Slope is equal to change in a y minus change in a x, and that is also equal to tan theta. And for that slope, particular slope, if it is equal to slope equal to 0, whatever value will get, that is the maximum height. So this is I given a basic example. It can be any equation. You just have to calculate the differentiation. We just have to find the differentiation, equate it with the 0, and calculate the value of the this particular variable, and from that we can calculate the maximum height of the graph. Yeah. So I hope that I have given very basic idea, rough idea of the differentiation. I will try to solve some of the very interesting and good questions in the next episode, and try to follow this so that we can continue with the other exercises. So I will continue with the different exercise on the differentiation itself in the next uh, chapter also. Yeah. Thanks.